All right. Hello. I see quite a few people. I think I see 172 people in here. So I'm going to assume that everything's up and running correctly. Thanks for joining my breakout. I'm Brian Jacob. I'm the CTO, co-founder of data.world. I'm going to talk today about how AI and automation are shaping the future of data catalogs. I prefaced some of this last in the panel session, so appreciate everyone joining. All right. So uh, topics today. I'm going to go through a quick acknowledgement. My intro section is a brief history of everything, not too ambitious at all. And then I'm going to talk about phase one, how AI is helping you govern and catalog and govern your data today. And then what I think will be phase two, where really having cataloged and governed data is going to help you AI. And I think that's the kind of switch that I see what's going to happen over the next 12 to 24 months. So really quick on acknowledgements, I just wanted to acknowledge that all the illustrations in this are courtesy of robots. I heavily used DALL-E and Stable Diffusion and Midjourney a bit to produce all the illustrations. I take no credit for them as I go through the presentation, other than coming up with the right prompts. So a really quick, brief history of everything. So I want to kind of ground everyone in, if you're maybe a little bit new to data catalogs, or if you kind of want to get my perspective on what data catalogs really are and how they fit into kind of just the entire history of knowledge management, I want to go through this section very quickly. So in the beginning, knowledge was in books, right? I think we talked a little bit about this even in the last session, that ultimately knowledge was written down, and as we needed to understand that knowledge with so many books, we needed to have the notion of metadata. So we invented the notion of being able to talk the data about data, right? The index cards that sat in card catalogs, talking about the books, so that you could actually search and find where the knowledge that you needed was before you actually had to go pull out the knowledge. Information expanded. I'm going to fast forward all the way through on this one slide through the Gutenberg printing press to the invention of the internet and the web, and data went digital, which just meant that we were able to produce a whole lot more information, a whole lot at much greater speed, at much greater velocity. And really, this is what everyone's dealing with within their enterprises. How do you keep up with the growing size and diversity of your data? And as data went digital, metadata went digital too. And this is really where data catalogs came in, right? A data catalog is really the descendant of card catalogs, but it's in digitized form, where the metadata, instead of being lots of little index cards, is digital pieces of information. But the metadata are data sets about your data sets. And crucially, that data is organized as a graph. So this is another piece of the history that I think it's important to understand, is that as you go back to kind of the evolution of AI, really over the last 40 or 50 years, there's really two branches. There's symbolic AI, which is the notion of how do I represent facts that I can do logical reasoning over. And that's really where the notion of knowledge graphs arose. How do I understand information as being about entities, which are represented as nodes in a graph, and relationships, which are the edges in the graph. And metadata is really a key canonical example of data that fundamentally is a graph. Thinking about your data as a graph, as entities and nodes, is really the way to think about metadata. Meanwhile, the other branch of AI that's been slowly kind of building along for that same period of 40 or so years is machine learning, right? Machine learning is statistical AI that learns patterns. It looks at lots and lots of data, and it understands how to repeat those patterns on novel new data that it sees. And so you're really almost building out a digital brain, something that basically acts as a neural network that we think is pretty similar to how humans learn and process information, that can look at lots of data, extract the patterns, and apply those patterns to novel data. Machine readable knowledge graphs make that knowledge available to AI. It really, what's happening now with generative AI is machine learning has gotten to the point where it has absorbed a lot of information, and it has a great baseline knowledge that makes it able to reason about things with common knowledge that looks very human-like in a lot of contexts. When you combine that with domain-specific topical private data from within your organization that are organized in ways that the AI can efficiently access it. That's really how you get get power. You really need to kind of bring these two branches of AI back together. And data catalogs are actually the way that organizations go from the vast troves of data that they have to structured understanding of what that data is and what it means, and use that to connect it up to the generative AI. One thing that we use heavily at data.world, and I think is kind of a key differentiator for how we look at this market, is we think about ontologies. So there is structured physical metadata about data, which are what are the databases, what are the tables, what are the columns, what are my BI dashboards, how are those things related, what's that data lineage. But as you take that data, what you really want to do is curate that data into structured ontologies around the concepts. What does the data actually mean? What are the real world things that are captured within the data? So again, I promised I keep that intro section pretty short. That's the history of kind of everything. So let's get down to something a little bit more topical, which is how does AI help you catalog and govern data? So right now, today, how can generative AI interact with your cataloging to help you by having robots do the robot things so that the people can do the people things? So when you're thinking about building out a data catalog, you start with your data estate, and it's probably more complicated than the four simple databases I have on the bottom of the screen here. But ultimately, the thing that every data catalog does in order to be a data catalog is it collects and catalogs the metadata. You are going out to these systems, understanding what physically exists, representing that as some kind of metadata, which ultimately forms a graph of describing those entities and relationships. How can we leverage AI to build and then to enable users to better consume that catalog strictly at the metadata level? For us, the platform that the features that we're releasing within our platform are what we call Archie-bots, and there's four kind of key use cases that we have focused on in this first release. There's enrichment. So we talked a lot about this in the previous sections. How do I go in and use generative AI to enrich my metadata to make sure that it's as well understandable by humans as possible? How do I then AI assist my search? How do I actually fold in natural language? I'll show you a bit here how we think about interfacing natural language search with kind of existed structured faceting search based on the knowledge graph. Really cool thing I want to show you is how we think about jumpstarting data exploration, how we really help people get into the data in a way that I think is truly novel. And then finally, we're going to talk a little bit about how we actually use that to tap into the data, looking at some of the virtualization that we talked about in the previous session. So first, I want to just talk about catalog enrichment. This is, I think, kind of the basic thing that everyone kind of understands generative AI can help with in any data catalog. I think where I think our implementation of Archie-bot's catalog enrichment really stands out is because we have that structured knowledge graph. We're able to pull in all the context that previously exists about a concept to use it to generate rich descriptions for resources. So if all you know is the table names and the structure from the database schema, we can work with that. It'll make the best guess it can. But if you have other additional human curated information that previously exists in a business glossary, all that context can kind of effortlessly be pulled in. And because the large language models have been trained on content from the web, the fact that we use standards like RDF and OWL for representing our knowledge graph means that we can use that to do some really, really efficient prompt engineering without a lot of kind of bespoke rework. The next thing is AI-assisted search. And this, I think, goes to some of the questions from the panel around, is search going to be natural language, or is it going to be structured and faceted? I think the answer is really, really both. How we look at this right now today is anywhere where we have our search box, you can now just type in natural language questions and sentences, and we'll detect that that's what you're doing rather than just typing in standard search terms. And you'll see this card pop up at the top of your search, which will basically say, look, based on what you typed in, here's what we understood you to want to query based on what's actually in the catalog. So it's taking the structured metadata about what we know exists in your catalog, interfacing that with your natural language to say, based on what we know about what's in this catalog and what you're asking, we're able to pretty quickly refine this down to these are the structured facets that we think is going to zero you in on what you're truly looking for. I can now kind of go either direction with this, right? If the natural language didn't quite get it right, I can still have access to all the same faceting and search tweaking I can always do, but I can also type in a follow-on question in natural language and continue along that way. So it's really kind of the genius of the and, basically using AI to automate the search that already exists. The next thing, this is the thing I'm really excited about, ideation and data exploration. The idea here is when I first come to a collection of data, I often want to know what can I do with this data? What does this mean? And textual descriptions are useful. They can tell you what's in the data, but really what I want to get to as quickly as possible is how can I use this data? We've always kind of had a collaborative notion to the platform where one of the big benefits of using data.world is that you can go in and see how other people are using it. But this takes it to another level where even if I don't have a lot of rich data about how other people are using this data, I can ask the AI to say, tell me what kinds of questions could be answered from this data based on the structure of the data and what we know about it. And so you immediately start hypothesizing what kinds of things could I use this data for? What are some use cases? And then taking this one step further, I'm going to go back to my diagram here of how cataloging looks. We talked a little bit about virtualized data, being able to actually connect into the data itself. So everything I've showed you so far, you can do just based on the metadata. But what if now that I've generated some of those useful questions based on my metadata, how could I actually go about asking those questions and seeing how the data in the catalog could help me answer those? This is where virtualized data access comes in. I can throw my AI at this problem to start from that list of questions. So this is kind of where I left off on that previous screen. These are some questions that the data in this collection could theoretically help me answer. And what I can do from here, you see at the bottom, and add them to a data set or project. I'm going to link this into a virtualized data set using our virtualized data access workspace. Over here on the left-hand side, I've seeded the questions that were selected into this project workspace. And in the query box, I've generated from a prompt, I've taken one of the text of this question. What's the total tax collected for all retail orders? And Archie has generated a SQL query against that virtualized data that was represented by what's in the catalog and executed that query. So in just a couple of clicks, I went from I don't know anything about what's in this collection of data to here are some questions that you might want to answer that would help you kind of spark your understanding of this data to dig deeper, to here's a running query using the schema of this database table to actually dig into the data and answer a business question. It's all fully explainable. I can see the query there. I can edit it and rerun it myself. I can give feedback that'll make the Archie better on the next iteration as to whether it did a good or poor job generating this SQL. And I'm not limited to just answering questions that were generated from the AI. I can also open up a new empty query pane and just type in the text of a business question, list all resource types with views more than 50, generate a SQL query from that. And I get the same behavior where my prompt gets turned into a comment describing what generated this, and Archie wrote me a query against the schema of this database that runs and gives me the answer right away. So I think there's a lot that can be done here in terms of going straight from business level question to answer based on structured information, and every step of the way it's governed, it's explainable. I can use this as a starting point and go write my own SQL. I can use this as a starting point and ask more questions of the AI. This is only going to get tighter loops with how humans are interacting with this as time goes on. So that was really my phase one of, I think, those are the features that we've already launched today. There's more things that we're building there, and I'm sure other catalogs are looking at similar types of things. That's phase one, where how the AI can help you do better cataloging and governance of your data. I want to now switch into how does the future look with cataloged and governed data helping you AI better. So going back through my build up here, you start from your data, you catalog the metadata, which gives you an understanding of what you have and how it all sits within your data estate. you virtualize access to that data. You actually give your users the ability to use the metadata in the catalog as a roadmap to then tap into the data itself and directly ask questions with SQL. But the real benefit to having that virtualized data, the real reason you have that virtualized data, is that at the end of the story, what you're building out is a highly structured domain knowledge graph. This contains ontologies that describe the real world concepts within the data, what they actually mean, and they have connections to be able to take queries against this structured knowledge graph and transform them into queries in the dialect of the underlying systems, so that when I go and ask a question in the natural domain language of this knowledge graph at the top, I'm able to live go consult my real data sources and pull in answers based on those data warehouses, databases, and other data sources. And this is really where your data catalog helps you leapfrog into the future of AI. LLMs are statistical machines, but to do real work, they have to have access to the governed data that can give you answers you can trust and that you can audit and that you can know, that you can explain how it ties back to real governed facts that sit within your existing data systems. A knowledge graph is really what a complete AI system knows, and a LLM, a generative AI technology, is really the how I can automate reasoning and thinking about that information. You need both sides to really have true business AI systems that you can actually use for real world use cases. The way we're doing this right now today is what we call the data.world AI lab. We're working with customers who have a fairly mature data catalog where they actually have some good understanding and some ontology layered into the knowledge graph that they're building, to say, how can we use this in conjunction with generative AI tools to build out domain specific applications of AI, which was really always the goal of building out a data catalog. Is at the end of the day, you want to be able to automate and deeply understand what your data is and use it to leverage AI. And with the advent of generative AI over the last year or so, we're really at the point now where we're able to do this hands-on with customers. One of our biggest successes here so far, that who are very open to talking about this publicly, is with WPP, which is a global advertising agency syndicate. They have been working with data.world for years, building out the data catalog of both first, second, and third party data within what they have internally, what they purchase for use, and what they use with their clients. And what we've been able to do with them recently around using generative AI to build out an ideation and project composition tool, where folks are able to come to the catalog, talk to it in natural language about the things that they're trying to achieve with their clients, and use that tool to build up the assets needed from the catalog and to answer the business questions that are needed to move those projects along. It's been just really, really exciting to see the payoff of spending years kind of curating this catalog, working with them to build up this very very well curated, well understood catalog from a very complex organization, and how generative AI is able to take that and turn it into real value in months. So this is really, the AI lab is the process by which we're working with customers one-on-one to really take their curated knowledge graphs and help them achieve the best value using generative AI. So just to recap, I think the title of this presentation was how AI and automation are shaping the future of data catalogs. I think we're in phase one right now, where catalogs are using AI to help you catalog and govern data. We're really excited about what we're doing there, and it's really kind of increasing the speed with which folks can implement and adopt data catalogs and build value. Phase two is, once you've done that, what can you do? How does getting to a catalog of your data help you accelerate your path to being able to truly do AI in your organization? And that is the end of my presentation. Thank you. So let's stop presenting. Jim, you're on mute. I don't know if you're trying to speak to everybody.
Yeah, sorry about that.
That's okay.
Brian, you got a question from Samuel Scordo. Says, how does data.world compete with Alation on this specific subjects of AI generated content?
Well, again, I think, on that specific notion, I mean, I think that, the differentiator for us on a lot of things, and it's no different here on this notion of generating content, is that knowledge graph underscoring the fact that we're able to pull in a really rich set of metadata, really curated from whatever structured metadata the customer has set up as their catalog profile, and use that as context to generate those descriptions, is the thing that differentiates. If all you have to go on is a set of column names and table names, then really it's then a matter of how well have you selected the generative AI tool, how much fine tuning and training have you done based on other observed data. It's hard for me to say how we compare on that, but where I think where I think we shine on this kind of generative curation is the notion that we can pull in really rich graphs, subgraphs of context that we can use to engineer prompts to send to the LLM, which makes the descriptions we get back often a lot richer and a lot closer to what a human would have written.
Thank you. Ryan, there are no other questions in the chat. You can either hang for a few minutes, or I can end the session, and we'll reconvening in a few minutes after 1:45 for visits to the Innovation Hub. So it's your call.
Well, I'm happy to hang and see if anyone has any more questions. I see Dan from InfoStage just posted a question as well, so I can at least address that. And then if anyone else has more questions, I'm happy to stay for a few minutes and take them, or we can move on to the next session. But he's asking about the bottom of the stack. Do we build connectors to a variety of sources? For example, SAP, Oracle, Salesforce, or do we leverage third-party tools for that part of the stack, since it's more mature and other tools already do it well? Yeah, it's a great question. We kind of take it. The answer is really kind of all of the above. So we do build bespoke collectors that go out and kind of take an opinionated approach to pulling in the metadata from a wide variety of systems. We have a framework for doing so. Really, again, I harp a lot on the knowledge graph architecture, but it's a really important one, because fundamentally our metadata is like a single structured open world knowledge graph built on top of standards like RDF. The complexity in building each connector that we build really comes down to how easily can I access the APIs and output of that system and convert it into that graph-based format, which all of our metadata lives. So it's really a very hub and spoke model. There's a core of every connector we build that's just our framework that's kind of out of the box and knows how to speak our internals very, very easily, and is based on a lot of open web standards. And then it's really interfacing with those APIs. We leverage a lot of third-party tools and components for that. There's a few companies that build kind of connectors and tools, and we've basically built what we would call a super connector, where we're using our internal tools to emit our graph metadata, and we connect to that super connector. So then anything that super connector can go harvest metadata from is just kind of for free pulled in. And then finally, this isn't exactly what you're asking, Dan, but it's a related question. What we find, especially as we go kind of larger enterprises, more complex businesses with a lot of history, there's a lot of custom or very long tail technology that we are never going to build an out of the box commercialized connector for, because the market for it is vanishingly small. There's the third party super connectors aren't necessarily going to have access to it. And again, sometimes these are completely homegrown systems that an enterprise built and has been operating for 30 years, and they're just not going to be able to get off of it anytime soon. This is another area that we really tend to shine and have a lot of success with some very big customers in this, because while most of those companies also have 30 other standard tools that they want to connect to, and we are very good at connecting to those, when it comes down to connecting to something that no one else really understands, no one is really going to have an out of the box solution for, our ability to work with customers to build bespoke collectors based on those APIs or the internals of those systems is something that other folks in the space really have a much harder time with. And we have a couple of customers who have an almost completely homegrown internal data ecosystem, and they thought the only way they'd ever be able to build a data catalog was to completely build it themselves. And what they've learned is that they can actually use data.world, get all of the kind of pace of innovation of new features and usability that we focus on, and maintain a very small footprint of a couple of custom collectors against those custom systems using our APIs, and get all the benefits of using a commercial best in breed system without the maintenance cost of having to actually build and maintain the entire data catalog themselves. And then see another question from Romain in terms of user friendliness. Where would you position your tool for data.world against similar tools in the market with a specific look at the new AI features? So we put a lot of focus on user friendliness. Something I think we talked about in the panel session is that there's a number of different personas that are always at play in a successful data catalog, and so we put a lot of attention into what is the user experience for those people who are really the kind of the first mile folks who are setting up the data catalog, the IT folks. What's the user experience for the governance team that's providing a lot of leverage out to the rest of the organization? And then what's the user experience for the end users? Thinking about the AI features then specifically, again, I think our curation tools, the description generation, things like that are really going to, we have a huge, I think we're already probably, best in breed at that, given our ability to leverage the knowledge graph and generate the best possible prompts. And that's only going to get better as people, the more your catalog, the richer your catalog is, the richer it can become using those AI features. So there's really kind of a flywheel effect that happens there. And I think also then on the consumption side, I showed the natural language enabled search, and I think we already had such a great semantic search foundation with customizable faceting, structured metadata that's really kind of customizable to whatever that organization needs within their domain. Being able to attach generative AI to that and now do natural language search that is really raised up to the level of that metadata is actually something that I think is really going to stand us out there. So I think we're very well positioned for our AI features to be really top grade in terms of user friendliness. And David, I would be happy to come speak at UT Austin since it's right here in town. Just feel free to send me a note. My email, I had it on my last slide there, but it's just brian@data.world. So anyone interested in reaching out, of course, feel free to reach out to me directly. But David specifically, I'd be happy to come speak at your class. I've spoken a few times at UT in various courses, so I appreciate the invite.
So, Brian, you've got 1 minute to wrap up before we sort of end the session and invite all the participants to visit the various innovation hubs starting at 1:45. So any final words of wisdom?
No, I appreciate the time. Really happy and honored that so many people chose to join this breakout session. Hope it was useful and informative. And if what I said here resonated at all, please come to our virtual booth, request a demo. Our team would love to talk with you and see how we could help you on your journey to AI and really understanding your data.
Great. Thanks very much, everybody, and particularly Brian. Good job.
Thanks, y'all. Appreciate it.